We want to start out learning to think like a programmer. When we're dealing with learning how to program, there are two main things that we need to consider. One is that we can't be ambiguous in our instructions to a computer, and we should limit complexity as much as possible. The first piece is related to how we usually think or how we are using natural language, where we can often use many different words to essentially say similar things. The more problematic case is that oftentimes words depend on the context in which we use them, either the words around them or the situation even in which they're being used. Think about sarcasm, for instance, right? It's the same kinds of words that are uttered in a different intonation, and all of a sudden it becomes sarcasm rather than an ordinary statement. So this is one thing. The problem is that computers cannot deal with such ambiguity. Programming languages are set up to be a clear set of instructions so that the machine can read through the instructions and make things work. The other piece is that of complexity. Beginning programmers oftentimes make the mistake to think up a piece of code or a problem that they want to solve with code and start writing from the beginning, write it all out, and then they begin their testing. That's really not how it's supposed to work, or rather, that's a really good way to give yourself lots of sleepless nights, because you will have a really hard time, depending on increasing complexity and so forth, to find the issues that you have introduced. So usually what we do is we think up kind of a bigger structure that we want to solve, and then pick out small boxes that can be implemented, that have a defined input and a defined output that we want. And then we write a bit of code that transforms the input into the output or does things, but we can test them because they are of limited complexity. And then once you have many of these boxes, blocks of code, functions, if you wish, you can start linking those together. And hopefully then your problem isn't how these boxes are linked together, because your code is well tested and you know that it works. Okay. So what we use for this is flowcharts. It's not necessarily the kind of tool that everybody uses all the time, but flowcharts are a good tool to ensure that we are writing down in a way that is understandable by a machine eventually, once it's translated to code, what we want to do. So what I'll walk you through here is a flowchart of the course. Right? We have looked at this in syllabus form. So a semester-long course is a big problem that probably should be broken down into smaller boxes. And this is what we do here. Flowcharts usually have a beginning, here, start. They can have decision boxes, for which I use diamonds here with question marks in there, and then there are outputs for these decisions that are often labeled with yes or no, and then there are other boxes that might be instructions or functions or some such. Okay, so we start out. You may have wondered at some point whether or not you needed to program. You came to the conclusion that no, you don't, and I tell you that you need to rethink that, or most likely you told that to yourself. Maybe your advisor talked to you about it. And so eventually you might be ending at, I guess, yes, I have to learn how to program. Now we're introducing a little counter here that is a variable that we set to 1, and we keep track of that variable. And then there's a kind of a process task here that is work through weekend lecture materials. Every week we publish lecture materials. So we are right now at N1, and you're working through intro and thinking programs. Here's a lookup table that tells us what the headings or the topics are for each week. Okay, so you are in week 1, you look at the table, you should be looking at intro and thinking programs. After that, you might be wondering whether that was interesting, useful, and accessible. If so, then please go ahead and play with the examples that we provide you. If it wasn't, then let us know. Let us know what issues you came across, ideally via Slack. Tell us which lecture material it was, and let us know your comments so that for the next group, we can improve that. And ideally, for future lectures, we can do that too. The examples too, were they interesting and useful? Yes, then you should go through the exercises. No, again, send us more comments. You should take a break. You shouldn't do that every waking hour. It is important in programming to take these kinds of breaks. Oftentimes you literally load a problem into your brain and you cannot solve it. You spend hours trying to figure out what's going on, why the code isn't running, and then you do something else, and later you come back with fresh eyes and your subconscious has been working on it, and you come up with a solution very quickly. So these kinds of breaks are quite important. Okay, then you should also work through the lab material for that week. Again, ask the question whether it's interesting and useful. If not, then let us know. If yes, then you can increment. You can add 1 to your variable. So n now is the old value of n, which is 1 plus 1, so n becomes 2. And at the end here, we've asked the question, is n smaller than 14? If yes, then we have more stuff to work through. If no, send us more comments about how things went, and we are done. We terminate the program. There are some bugs in this program that I just showed you, and they will become homework for you. I hope this provides you a little bit of a tool set to visualize both the problem and the related problems that you'll come across for the projects that you might want to tackle. I hope that you understand from that example a little bit better how you can break down the big complexity of, in this case, take a course, but we can go back to the cases of visualize data from 1,000 sensors that are distributed in the field somewhere into smaller issues that you can more easily handle. You could write out your entire degree program that way. You can write out your manuscript, your thesis, dissertation that way. And it is often useful to know which boxes depend on what the inputs are that are required, what the outputs are, and then reorganize the program in a way that it works, but also have a guideline that you can easily implement, probably already having debugged a lot of flow problems or some of these minor bugs that I introduced here, without having to even start an interpreter that translates your instructions into a runnable machine code.